Hey everybody, I know it's not Wacky Wednesdays, but I want to see it. Oh, I can't hear him. Oh man, I get to see him, but I don't get to hear him. It's Wacky Thursdays. But I can hear some Mega Man music. That's what I can hear. Are we ready to do this? Are we ready? My hair is green. You can see the green in my hair. I'm ready. You guys got to hear the Wacky Thursdays. I need to make the Thinking Thursdays. We're ready? Let's get this loaded up here. Let's pull up some punch out here so we can get the quizzes going in the background. Get the quizzes going. So Alex is excited to listen to it too. Ba-da-da. So we're going to do, I think people wanted confidence intervals for the proportion, which is the one due tonight. So let's start doing the quiz due tonight. Let's hop over here to the main screen. How'd we do on that transition? Oh wait, desktop. What is going on? What happened? What? What? Are you guys seeing a white screen of nothing? When I go to desktop, is it going to a white screen of nothingness? What is going on? One moment. Let me click the desktop button again. Oh, that's weird. I don't like that. What's going on here? It's a little window? Well, let me do this. We're going to do speedrun screen. That is so weird. Well, you know what? I think we might have to use the speedrun screen. I'll have to fix this later. Why does software suddenly break when you've done nothing to hurt it? I'm using so many programs to do this. It could be one that's broken. There we go. We're speedrunning these. Yeah, I don't know what's going on with that. I'll have to reset computer or see what's happening, but speedrun screen's currently set up. So we'll see. Can everyone see the questions? Catalog question. Thomas, you asked, and you shall receive with the catalog question right here. Glad I wasn't. I usually do some checks in the morning to make sure it's working, and I kind of just booted up, and I'd never seen that error. I have no idea why that error would occur. No, enough about that. My lighting works nowadays, though. I can change the color of my lights. Let's do the catalog question here. A catalog sales company promises to deliver. We'll time all these. Why not we time these? Why not? A catalog company promises to deliver the orders placed on the internet within 3 days. Follow-up calls. So this one right here, vitamin D, we can do that next. So with this one right here, we have to know our interpretation. The interpretation is, I am blank % confident that the true blank is contained in the interval blank to blank. So when you look at this interval right here, this interval says nothing about the what level? This says nothing about the blank level. Nothing about it. Nothing at all. Ned Flanders. Classic Simpsons. It says nothing about this. It says nothing about I am. I am what? It says nothing about I am this confident. So it doesn't give any confidence level. So, oh, thank you so much. Hey, throw me an email, B. Stevens. I appreciate that. Hey, this is fun. We got all the music here. We got Mega Man. So I appreciate right there. We got the Mega Man to help us out. You get some Mega Man for that. It tells us nothing about the certainty. Some Mega Man right there. Appreciate that. So it applies certainty. This right here does not tell us anything about the confidence level. We don't see anything related to confidence level. So it's not correct because it doesn't say anything. It gives us certainty. It implies certainty. We don't see the I am blank % confident that the true blank is contained in the interval blank to blank. Now, when we do, great job. Look, we got some answers coming through right now. When we see this right here, This is talking about 95% of all sample customers. So when you look at this right here, we make a confidence interval from something to estimate for something else. Confidence intervals are made from something to estimate for something else. So glad to have you, JM, in the chat. We make a confidence interval from something to estimate for something else. We make it from something to estimate for something else. I'll give you some hints. You ready? The possible answers could be... Some of those words are going to be used here. These are good reviews right here that we need to understand. We make a confidence interval from this to estimate for this. So you'll always know this when you make a confidence interval. You'll always know this. And you're using it for insight. From samples to populations. Josh, you're right. You got it. We make a confidence interval from sample data. So we collect some sample data, and then we use that to say, I am blank % confident that the true population proportion. So population proportion is just one thing we can estimate. So we try to figure out from the sample some estimate of the truth. So this one right here is saying 95% of random samples. That's not what we do with confidence intervals. We don't do that. So we would say I'm 95% confident the population proportion is contained in the interval. So this is not correct. One of my least favorite ones because it's much less than that would be it. Much less than it. Because don't worry, it's wrong for multiple reasons. It's like it's wrong in so many ways. 95% of all random samples will show. Once again, this one's talking about random samples here, though. This one's talking about random samples, and Streamlabs should be on the job. Come on, Streamlabs, you got this. This one's talking about random samples again, so this one's definitely not correct because we just said a moment ago that we're going to deal with population parameters, and that's what we're trying to estimate. So this statement is not correct because the interval estimates population parameters, not sample statistics. Maybe I'll look at Streamlabs here in the background, make sure it's running. And remember, sometimes it takes the 5 to 10 minutes to boot up. We've seen weirdness with it. Next, we see 1 is 95% sure. Wait a minute. What's the error in this question? I need some help with the error in this question. There's a big error. It almost sounds like I am 95% confident. And then it's got the between blank to blank. But there's an error later on. Who sees it? I need some help. Lots of help. Who's got the error in this one? Because remember, our interpretation is supposed to be I am blank % confident that the true blank is contained in the interval blank to blank. I am blank % confident that the true I am blank % confident that the true blank is contained in the interval blank to blank. And Thomas, you are right. We're talking about the true proportion, not the sample. And so what's interesting is we actually know for the sample customers, we know what the sample customers showed. They showed 84%. And why is that? We've got it highlighted over here in our Word document. We can show that this is the center of the interval. P hat is the sample proportion. And we know how many of the sample customers got their orders within 3 days. So we don't estimate that. That's the sample proportion. So we wouldn't estimate that. We know it. So this is not correct because we know that 84% of the sample customers got their order within 3 days. Next, we go right here, and on 95% of days. Now, this one's weird. It's wrong. But the issue with it is we're not estimating for days. We're saying, like, for all customers for all time. You could do it that you're estimating the true proportion of days where customers receive their orders on time, but that's not what the question asked us. They went to customers and they asked, it said follow-up calls for randomly selected customers, and they asked the customers, did you get your order within 3 days? It's like Amazon being like, did you get your order within 3 days? And they did follow-up calls, so they're not going to have non-response bias because they're going to make sure they get those responses. Test due today. So they, right here, are not doing the population parameter that they're trying to estimate. So for this one, the interval is about the parameter, not the days. So you could do it where the parameter of interest would be the days, like the proportion of days where customers, I don't know, the question would totally change. Because remember, the parameter, who can say in chat, secret 50 points right here, who can tell us in the chat what the parameter means in words? The parameter, see if points are working. The parameter is the thing we are trying to something about the population. The parameter is that thing. Streamlabs is back on the job. The parameter is that thing we are trying to, like when I say the parameter of interest, it means we're interested in it. It's the thing we're trying to, like, something, who knows, 50 secret points right here. Who's got it? It's that thing we are trying to, like, who's got a word? It's like, it's the thing we want to, I know someone's got me. Someone's got me here. Who's got it? Understand. You're right. Yes, I'll take that, Elizabeth and Carly right there. You're right. So what we're trying to measure, it's what we're trying to understand. When you say the parameter of interest, it's like, I want to understand the proportion of my customers that get their orders within 3 days. So your population is your customers, and your parameter of interest for the population, that's like the big way of saying it, would be the proportion of people who get their customers within 3 days. So that's why we say, I am 95% confident that the true proportion of customers that get their order within 3 days. So you know what? If it helps you out, when we do this saying right here, what goes inside of here is parameter, not orameter, parameter of interest. That is what goes inside of here. We always say, I am blank % confident that the true blank is contained in the interval blank to blank. The true parameter of interest. And true is kind of redundant at this point because it means, because the parameter of interest is the truth. So you could literally, I like to say true, but the parameter of interest is the truth. And so by saying the population proportion of this, that is also truth. I had a professor, so good to see stats teacher in here. I wonder what they do. I wonder what they teach. Oh, they're a math teacher, they said, right? Whew, we need some help from them on some, they can teach me some differential equations, some ODEs or PDEs. Yeah, I can't do PDEs. So math teacher, if you're still here, I need help with some Laplace and some heavy side because I can get these right. You ready? What do we say to my Pearson? You know what we say in the chat. We say, not today. Not today, my Pearson. Not today. We get this right. We do it. The secret to teaching is coffee. They probably know that also. Not today, my Pearson. Not today. It's probably my favorite say we've come up with this. What's up, Andrew? We even got Andrew visiting in right now. Good to see you, Andrew. I think you're taking 474. Yeah, so we will, Andrew, check out some of the new videos we got. So good to see you here, Andrew. I think someone else had another one. Vitamin D, you bet. Let's do some vitamin D question. We got the timer going. We got the speed runs because we broke a screen. Starts in 7 days. I'll be posting the syllabus, I believe, this weekend. Yeah, it starts a week from today. What am I doing? We got this. First session last summer was when my fiance started her veterinary. And I went and visited, no, it was second session because I went and visited her for the 4th of July because I was just remembering that. And I was like, wait, it was second session then because that's when they do that thing. And so, yeah, that's when she started her internship. Okay. Oh, no, she had already started. She had moved. Yeah. Yeah, it was around because she had been there and I went to visit her. Okay. Here we go. 4th of July. Yeah, no, it's a huge bummer. But you know what's not canceled? Vitamin D question's not canceled. Let's start the speed run. We broke the other screen, so we'll fix that. And I have no idea what's going on with that. Probably need to turn the camera off. Forgot to turn it off. Vitamin D, yada yada, is bad. Some Seinfeld right there. We're going to take a sample of 2,400 children, and from that sample, we see that 22% of them have vitamin D deficiency. So I need to identify the notation. Notation. People in the chat, send me your power. Tell me some of the notation here. Who knows any of the notation? While we jam out to some Mario. I need some of this notation. I need to know what that is. And I need to know what this is. Because without the notation, I can't solve these problems. You don't know the notation, you can't solve the problems. Oh, nice job right there, Jared. Excellent work, Jared. 50 points. And Carly helping out with that notation. Great job right there. We'll do philanthropic next. You got it. So let's open up a new word sheet here in the background of the speedrun screen. Let's check it out. We've got here that N, and you guys are helping me out by putting in the chat. I no longer have to switch between screens. That's the secret. That's why I asked for you to do it. Now, what often confuses people, where I see a lot of confusion on these problems, is people then say, well, how do I get Q hat? Very common question. Q hat is found by 1 minus P hat, which probably the people in the chat, 50 points, who's got it right now. People are going to start putting Q hat. You guys are on a slight delay, but I know you know what Q hat is because you do 1 minus P hat, you get Q hat. So Q hat and P hat are complements of each other. Important thing for this test, that we see that they add up to 1. You can quickly find Q hat and P hat by just doing 1 minus the other one, just to see on the calculator. There's what we were doing previously. We do 1 minus p hat, and we get q hat. So if you're afraid of your mathematics not working, it's always good to double check. But then I always like to say we should solve it in our head just to double check and to make sure we got it. Just, just practice some mental math. Never hurts. Because then you can be like, hey, I didn't get my right change back. Just always do the math in your head. Give it a quick check. And so now we're almost done with this problem. But here's where people get stuck. When they get to the percent confidence for the interval, they're like, what do I do with this? This is where we call our friend Mr. David Emmaline. He named the applet after himself so he could have everybody say his name. Smart man. I don't know. I had my coffee. That's what happened to Brian. Brian drank his coffee. I did not want full screen. Brian drank his coffee and woke up. And here is David Emmaline's famous applet. Now, there's many ways to do this. There's Z tables, but you know my policy on Z tables. If you find one, burn it. It's fine. But I like the David Emmaline applet, if anyone's wondering, because you can input something like value from an area. Now it's going to shade whatever part of the curve I want it to shade. What you could do is you could find a 98% confidence interval by doing this. Does anyone understand why this would be a 98% confidence interval? Who in the chat for 50 points can maybe explain why this is a 98% confidence interval? We'll do it. We got that. You got it, Jose. Why is this going to give me the Z-score for a 98% confidence interval? Why does this work? I mean, that's 1%. But it's 1% over here. Wait, if we put 1% over here, that'd be 2%. It would kind of look like, I mean, we could see what that looks like visually. Let's do this. Let's do that. Wait, it was 2.326 before. What if I go to between? So the point is you can use it. You can do the middle 98. That's probably the best way to do it. You guys have seen me use code in the background before where I do it in R. And just so anyone was ever wondering, if you're wondering why when Brian often codes this in R, Brian usually writes his code. I'll write it down here so you can see it. I write qnorm, and I'll write something like this. So that's what I was writing into qnorm, is I was writing qnorm 1%, and it was solving for me. It was solving for this number right here. So when I do qnorm 1%, it finds the first percentile, but that's because a 98% confidence would have 1% on either side. Now, that's way more detail you need to know. You don't need to know about qnorm, but it's just how you can use these applets to find different answers. And why does code help? Well, because this gives me very much decimal place accurate. The answer here is 2.326, but I can see the more decimals using code in the background. But the big thing is, if you want to do a confidence interval, just tell it the numbers you want. There you go, 98% confident, and put it in the middle. Because the confidence interval is the middle shaded portion. We're going to take this number right here, 2.3263. There's the other decimals. And we're going to go back to our Word document where we started writing our notation. So we're going to add in the Z-score here. The Z-score is 2.3263, extra decimal if we know it. And now we have, great job, Carly, right there. We have the notation we need. We're going to zoom out just a little bit, not destroy the illusion. Illusion not destroyed. And we're going to go right here and go to p hat plus or minus a Z-score. It sometimes has a star. It just means you get to pick it based on the level of confidence. And then we go to p hat plus, p hat q hat over n square root. There we go. So we have every bit of notation that we need. Does everyone see this? All the notation's been marked. The question's been destroyed. We got this. So let's go right here and throw in all the notation. I'm going to erase all of it. Somehow write it inside of here with my horrible handwriting. Oh, these numbers aren't too long, so we got this. 0.22, 2.3263, 0.22 times 0.78, and then 2400. Let's clean up that radical right here. That radical. It's interesting as I keep thinking, like, as I get older, I'm like, I wonder if they're like an 80s kid like I am, that math teacher right there. I love when we have visitors. It's so cool. And I wonder if they got a YouTube channel too, because I get inspired by a lot of people who make YouTube channels and teach on YouTube. So I've there's so many good people. There's what is his name? You guys are like, that doesn't help, Brian. He does a bunch of calculus stuff. I'm sure the math teacher knows of him. He solves like a bunch of integrals and everything. His channel is awesome. I use his channel to help me out. Remember to do mathematics and integration and by parts and all that good stuff. It's on the Stat Tool 1 webpage. If someone can post to Carly, or I'll show you where it's at, Carly, here in a second. You got it. We'll do that next, and we'll hop to more questions. This is the solve for the interval right here. We've solved all the notation. So we go in here, we put it into the calculator. My favorite way to solve it is to solve the top part. We solve divide by. This is now the standard error of the interval. I've solved this portion. I'm going to multiply this by 2.3263. You should be thinking, what did Brian just solve for? Brian just solved the standard error times the z-score. That's the margin of error. So I've literally just solved, that's 0.01967. So we're just rounded to 0.02 for nicety. And yeah, if we just delete all this right here, can somebody remind me of where we can find our equation? Yeah, it said I was wrong. No, carry all your decimals. Carry all the decimals. I got making random songs. So make sure to carry all your decimals. If you want to send me your numbers, and I'll double check it here. Make sure to enter this into 3 decimals. That's 24. Did I luck out? Watch me get it wrong. Yep, Carly, nice job. It should be there. Tell me if it's not. Let me look at my decimals on this. That rounds, everything rounds up, and it says round to 3 decimals. Yeah, that's the thing, Jared. It'll get you with the percentages and stuff. Good job, Jared. If you get something wrong because of percentages, just tell me and I'll fix it. Nice job, Carly. Carly, 100 points, helping out. Posting those links for people to see. Explain clearly what this interval means. I am blank % confident that the true blank is contained in the interval blank to blank. So we are 98% confident that the true proportion of children deficient in vitamin C is contained within the interval. It's not random selected children. It's the true proportion of children. I wish they said true or population proportion. You can't get everything you want, though. About 98% of random samples will produce... What are we making again? What are we making? About 98% of random samples will produce what? What are we making? I'm not going to look at the answers. I'm going to tell us what we're making. What are we producing? We're producing these things. So about 98% of random samples will produce... Oh, Adam. Good to see you, Adam. Just saw you in the chat right there. Hey, so good to see you, man. I think if you're taking 324.75, I'll see you around again. And if you're not taking it, good luck in your journey, your education journey. So hyped today. They're going to produce confidence intervals. And then the confidence intervals try to contain what? Confidence intervals hopefully contain the population parameter, or the true proportion. So, oh my gosh. The intervals contain the true proportion. Nice job, Adam, right there. Amazing work. Yep. And let's see. Not today, my Pearson. Not today. That's our new saying, Adam. Not today. We got a question wrong every once in a while, and it's my Pearson's tricking us. You misread a question, it's very easy to get something wrong. We all make mistakes, even me. It's believed that as many as 18% of adults, let me see here, I think Jose, I'm gonna double check. Jose had one, and I think there was one before that, a philanthropic organization. So we're gonna do Alyssa's, then Jose, and then Thomas's. Yeah, if it asks for a percent, Hunter, make sure to move around the decimals. If for some reason you're wrong because you enter percent as decimal or decimal as percent, just tell me, I'll fix it. It's a number. I care if you know how to get the number. I don't care if it's, my Pearson's being mean. We don't say, my Pearson, why you do that? Let me see here. What was a philanthropic organization? A philanthropic organization. Okay, I need you guys' help again. Need you guys' help here. I need to know the notation in this question. I need to know the notation. I am stuck. Let's see. I'm stuck. This will help you study for the tests. Better you know the notation, the quicker you can see it, you can get done. Hunter, amazing job right there. 50 points, Hunter. You are correct. Sample size, Alyssa, 50 points. That's the sample size. We've now identified sample size. There's 2 or 3 more things we can identify. Close. Carly, be careful. Close. Carly, 50 points. Alyssa, 50 points. Yes, Alyssa is correct. That is X, which we will use to find something Carly was figuring out. Yep, we'll do that one. Yep, we got it on the docket. Yep, and then so we're missing a few things right here. Keep going. P hat. How do we get P hat? Who's got P hat for me? So we have enough things in the chat right now. If you're watching the chat, we have enough things in the chat to figure out the rest of our answers here. So let's start up a new sheet right here. And we now know what X is. We've identified X, which is the number of successes we have. So X is this right here. And N is this right here. P hat. Oh, nice job, Hunter and Alyssa. Great job. Great job. And we got some Q hat in the chat right now. There we go. And now we just need one last thing. What are we missing from the equation down below? I'm going to write the equation right here. We're missing one thing out of our equation. This is where people usually get stuck. Maybe someone's saying it. I was writing it as I was saying that. I started to look over. So what are we missing from our equation that we don't know right now? We're missing one thing. The z-score. Now, every z-score is related to a something level. Every z-score is related to a what level? And this z-score was a... what percent? I'm giving away the answer. So every z-score is related to the level of confidence. Nice job, Alyssa, right there. So every time you get a z-score, you have to know the percent confidence level. And so we just go here to the David Emmaline applet, which link in chat. So the David Emmaline applet has the link in the chat right now. And then we have to select value from an area. And then 1.96. Thomas is 1. And then Thomas, wait. Go to the link, Thomas. And make the graphic look like that, and you'll see 1.96, one of the big numbers in stats, or 1.95999. Sorry, stats people. There's more decimals. There's always more decimals. We can check. Watch this. You ready? R is going to show me up. R is going to show me the more decimals to it. There it is, right there. There's even more decimals. When you started this live, I was watching it while waiting for it. Oh, so cool. I like vets a lot. I think veterinarians are some of the best people in the world. I'm a little biased though. Here we go right here. Here's the 90% confidence roll. This even relates to other questions. Did everyone see this visually, that a 95 going to a 90% confidence roll would literally make the interval smaller, going from a 95 to a 90? So when you go 95, 90, it goes in. Response bias. Fiance bias. That's what it is. But yeah. Would it be a response bias? No, it's just that some people have people in their lives. Yep, and someone's got the answer. Nice job, Alyssa. It's not a bias. It's just the way it goes. Vets, I just see how much they care, but they care about. I can't imagine a vet not caring about animals. I mean, I'm sure there's vets that don't, but still. You got it, Alyssa. Yep. And so now we go back to our sheet, and on the sheet of paper right here, we will just plug in the numbers. Now what I'm going to do is I'm going to do a true, but does everyone think they can handle it from this part now that you have identified for this problem all of your notation? You've identified z equals to 1.645. Does everyone, you got it now, right? Thomas, do you have questions on it? Which part are you stuck on? If you notice here, we plug in the p hat, the q hat, you divide by n. This is good on a TI calculator. The little calculator I use, like on the computer, it doesn't work so well. Do you have a TI calculator, Thomas? It'll be able to carry enough decimals. Just follow it through slowly, put in all the numbers, and this will solve out for the interval. Does it make sense? Tell me if it doesn't, and I'll be right back because I'm not leaving. But I'm going to show you. We're going to do a real speed run of this question. You ready? Here's the real speed run of it. You ready? 427. Yeah, tell me if there's a problem, Thomas, and we'll come back to it. 4527. You ready? Here we go. Here's the real speed run of the problem. Oh, we didn't start it. I can't click it. Ah! All right, 4527. Z is 1.645. And then we highlight our code. And there's the solve. It is solved, and this rounds it for me. So it's 44 or 4.42. And actually, I could fix this. There we go. 4.42 to 4.64. That should be right. Looks pretty accurate. Let's double check. All this did for me was solve out the equation. It literally just plugged in the numbers. Identify your x, identify your n. From x and n, we get p hat, which is the sample proportion. From p hat, we get q hat, which is the complement. So when we go the final answer, do we change? Let me see here, Hunter. Let me read it. When we get the final answer, do we change that and the p then? Yeah. What you're going to do is, usually I solve for the margin of error first, and then I add and subtract that from p hat. Does this all make sense right here, Hunter? From here, it's just plugging in the numbers, and then I usually solve for the margin of error. So actually, I can tell you what the margin of error is. The margin of error, I have it saved right here. The margin of error is whoops, whoop. What happened to my thing? And I'm just double checking my work. Oh, that's around to 4 decimals. So is that really the margin of error? Yes, margin of error. Cool. We got that. We got that. So the margin of error, if you solve this out mathematically, yeah, it's a pretty small interval. It should be something like that. It's like 0.01. That means there's been a carrying issue. Alyssa, do you have a TI calculator? Are you using a TI calculator? Because I'm about to show you a really quick way to solve this. So ready, Alyssa? You do? Okay. With your TI calculator, I want you to click Stat. And on the Stat button on the TI calculator, I want you to go to Tests. So you'll see a button on your calculator that says Stat on it. And it'll be right about in here. Do you see a button that says Stat? Can't draw. Click the Stat. And then at the top of the screen, go over to where it says Tests. Worst drawing ever. You got that? Scroll down till it says 1 prop z int. Are you on that right there where it says 1 prop z int? I think it's A. If it's A, I'm just going to be like, I've done this way too much. Is it A for 1 prop z int? It's... I've done this too much. Oh, no. No. Okay. What do you see on the screen? What do you see that it wants you to enter in? I know what options it gives you, but you should see them on this screen. What do you see for it that is asking you to enter in? What do you think the sea level is? Good question. What is sea level? Because there's 3 things. Sea level we don't have on here, but sea level is related. Sea level is related to one of these. What is sea level related to? What do you think sea level stands for? Like, what are we building? What are we building again? What are we building? Confidence interval, confidence level. So the sea level will be related to the z-score. So my sea level would be 90%. You're on 1 prop z test. Alyssa, I believe you're on 1 prop z test. Now watch out. A might have been something else. Sometimes different calculators have different things. But if you're seeing P0, then that's a 1 prop z test. Make sure go back to it and look for 1 prop z int. Int stands for interval, and 1 prop z test is a 1 proportion z test. So with the P0, that identifies to me that's a 1 proportion z test. Yep, good job. And we'll be doing that soon. 1 prop z int, you got it. Nice job, Hunter. And then you put in the numbers, you put in your confidence level, solved. You could beat me. It took me like 10 seconds to do this code right here. Once I have the numbers entered in, I just simply run the code right here, and it'll report the interval for me. And if you notice, the interval has a margin of error of about 0.11. So this interval could simply be written 4.527, and then we could go plus, well, we can see what them. Plus negative 0. What is it? Can't think. Oh, it's like so close to that. It's like that. And then 0.109. It's like, what? Oh, I didn't concatenate. I don't know how to code. Oh, it's not that. What am I doing? Oh, because it's like a decimal. It's like this, I believe. What's the margin of error again? That's the margin of error. It's 0.1%. 0.1. Oh, and then, wait a minute. Sorry, Brian's thinking to himself. I should put my code up here. 4. I don't want to get it wrong. 2 seconds. Brian's investigating his code. Here is the margin of error. Let's turn it into this. Oh, times by 100. Yeah, okay. Now it'll work. Times by 100. There we go. That's more decimals to it, though. What do we do with the interval that we got on the calculator? Do you see something? Now, here's the thing, though. The interval you got on the calculator won't look like this. The interval you see on the calculator is going to look more like this. Is that the interval you're getting on the calculator right here? The second thing I've shown you. Does that look similar? And I think my code, because I think you guys can figure out this code and what the differences between them. Does this second one you got right here look like what you got on your calculator? So what do you think you need to do to that interval right there? What do you think you need to do? You got it. Thomas is saying it right there. So although you probably don't code, you're like, wait a minute. I need to take this whole thing, whatever I got, I need to times it by 100, and it'll give me the answer. And I did some ridiculous coding stuff. But you notice here, I just take whatever it gave me and I times it by 100, and it'll turn it to percentages. Does that make sense? So you can take a proportion and times it by 100 and turn it to a percentage. I like this because it looks better than my handwriting. So all this fun stuff right here. Fun stuff. Who got the philanthropic question? What was the answer? It was 4.42 to 4.64. Let's go back to the philanthropic question. 4.42 to 4.64. As long as we... Do you guys think... Nice job, Whitley. Do you guys think... 50 points to Whitley right there. Do you guys think that 4.6 seems plausible? Because I think the true proportion of people who will respond to our mailers is contained in the interval 4.42 to 4.64. Do you think 4.6 is a number that I should be like, yeah, that seems... I believe that. Why would I believe that or not believe that? The question could say, do you believe this? That looks too small of an interval, Thomas. Tell me your numbers here in a second, and I'll solve it for you. Tell me your X and tell me your confidence level, and I'll check your work. Since you're here, I'll check your work, and then I want you to go back and I want you to look at the error. No, that... Oh, should you... 4.9. And tell me if something weird happens with the rounding. I thought that was your interval. I was like, that's way too small of an interval, like a 1% interval. It's between the intervals. See, I'd believe it. Not today, my Pearson. Not today. Yeah. So did you have about 5,000 people respond? Or like 5,100 respond, Thomas? Like it was like 5,086? It was like 5,086. Maybe 5,060. Something like that is your X. Was your X about 5,060? 5,035. Yeah. I've done this problem way too much. If I had been right on the dot, I'd be like, no way. Yeah, that seems about right for the lower of the interval, because that'll be the lower bound then. I've done these problems a lot. 10 years of doing the same problems. Can we do... I think Jose has the next one. Let me go up to Jose's question, and then I think Jared. So Jose's... And then wait, Thomas has one. Was Jose next, I think? Jose has one. During routine, a doctor knows that 25.5% of their patients... Got it. During a routine... Editors believe... What do they believe? Okay, here we go. During routine screening, a doctor... We got to start the clock. Start the clock. During routine screening, a doctor notices that 28% of her adult patients show higher than normal levels of glucose in their blood. Automatically, when you hear this is like a sample they took, awesome, Alyssa. Oh, it was the one, wasn't it? You got lucky there. Hearing this, some medical researchers decide to conduct a large-scale study. Okay. Hoping to estimate the proportion to within 5% with 99% confidence. Oh. It's an algebra problem. Where's the math teacher at? Math teacher, where you at? We gotta play some Punch Out and bring him back here. Well, that's the wrong button. We need the math teacher's help on this one, because this is an algebra problem. Okay. We got 5%. What is 5%? I need some help here. What is 5%? They're saying like within 5%. So that 5% right here is a what? Like within 5%. It's 0.05, you're right. It's 0.05, but it's like within... This would be one of the ones I would think that's pretty... It's harder to do. It's solving a math problem with statistics. Sorry, math. I loved your math. And then you turned into real analysis, and I didn't like you anymore. The 0.05 is the margin of error. They're like, real analysis, that's easy. I'm like, no, it's not. That stuff destroys me once you stop talking about real numbers. Or like you stop talking about the numbers that are real. The 5% right here is the margin of error. The 99% is telling us our what level. The 99% is going to tell us something really specific for this. That's our level of something, which will then tell us this. Confidence, you're right, Hannah, you got it. So the 99% confidence we're going to use right away. We're going to use that information to say what is the z-score for this problem, and it's 2.5758. I can memorize stuff. That's what I can do. 2.5758 is the z-score for a 99% confidence interval. And we go back here, and we say that this is the margin of error. So they want to know how many selected adults must be tested. What do they want to solve for? They want to solve for what? And there's a trick to this problem I'll explain, because part that it doesn't tell you. 1.96, Jared. 1.96. And then make sure, I'm going to drop in the chat again. Hop over here to the David Emmaline applet. Dropped in the chat right now. And then use the applet. Double check. Like, I might not be telling you. Is the truth. 1.96 for a 95% confidence interval. You're right, Hannah, you're right. They want the sample size because they're saying, let's make a confidence interval with a 5% margin of error. So they want to estimate within 5%. So they want a 5% margin of error. So the information given to us in this problem, I think we have it mostly in the chat. This problem is solve for n, not with highlighter. That's not what we want to do. The information in this problem is solve for n. So we have here solve for n. And we're trying to figure out the sample size. And so they told us that the margin of error is equal to 0.05. So we know the margin of error. The z-score was obtained from knowing that it's a 99% confidence interval. So because it's a 99% confidence interval, the z is equal to 2.5758. Once again, this is because it's a 99. I think I said 98 a moment ago. It's because it's a 99% confidence interval. And let's double check. I keep switching the number. It is a 99% confidence interval. So because it's a 99% confidence interval, it will be a z-score of 2.5758. Once again, this is obtained from the David Emmaline applet or any sort of applet or table you want to use to confirm that the z-score is 2.5758 if you know the extra decimal, because you've been doing this for a long time. Okay, so I just laugh at myself. We have a formula here that we wouldn't think of. Well, I mean, you'd probably think of this. Most people would automatically start writing down this formula right here, and you'd be correct to, but you don't need the whole thing. And we're missing something. This is where people are like, wait a minute. Okay. So right here we have the full formula. But what do we not need on this? I need some help here. What can I just be like, nah, we don't need that. What can we just kind of chop off of this? Because we're only talking about one thing. It wants to, yep, the whole, you got it. Nice job, Jared. Yep, we're just going to be like, nope. And guess what? Everything I've highlighted right here is the what for the interval. What is everything I've highlighted right there? That's the what of the interval. I did have a plus or minus next. You got it, Jared. Nice job, Jared. It's the margin of error, Jared. 50 points right there. You're on fire with all these answers. You got it. So we know what that equals. We know what that equals. We know what z is. So z was 2.5758. Now here's where this problem is a little bit confusing. Let me double check. I think I know what it wants me to do. Oh, wait a minute. Wait, they estimate. A doctor notices that 26%. Well, I should have put that down. Whoops. There's another one that does a trick. This one does not. This one uses p hat equal to 0.26. Now we know q hat. And since we know q hat, we're good. Now, probably one of the easiest things to do right now is to start multiplying stuff together. Space pen. I'm sorry, Space pen. You will return in another lecture. I know Rainbow Pen had its day, but Space Pen will return. So right here, we've organized our equation, and we go right here. We start multiplying, and we do 0.26 times 0.74, and that's going to reduce to that. Now, what I'm also going to do is, let me think here. Man, algebra. Algebra is so much fun. We could square root it, right? And we could do square root of n. Yeah, so we could square root this. Let me square root this. Boop, square rooted. Okay, so now let me scroll down a little bit on this page. This number I just obtained, 0.0438, is this right here. And that's over square root of n because you can distribute the radical. You can literally take and put this radical here and this radical here and solve for that. So we just got that out of the radical, which is a big goal of doing a lot of this stuff. And even more so, we can then pull that apart off of it. And literally, you know, like you can just take this off of this and multiply it by it if the screen would stop moving up on me. So 0.438, we can take and do this, and 0.438 over here. So just doing that right here, and then we put this right here, 2.5758. And then we have 0.05 on the other side. And so then we divide by 0.05. And then, let me not do it that way real quick. I knew you were going to do that. The math teacher's like, what are you doing? When I was in school, I'm going to put the square root, it's not off the screen yet. My teachers would wonder how I would do stuff, and then they'd be like, you shouldn't do it that way. And I'd be like, I'm sorry. Okay. And then look. Oh, look at that. Now it's looking a little bit prettier. And what's really good about this is we're going to do something here in a second to make this look way nicer. Is we're going to then put it in notation to make our lives easier. So this is 0.05. Okay. So if you look at everything I've written right here, we can make our lives a lot easier by thinking about everything we have right here and just putting it back to notation. And let me remove that 0.05 on this. So then, oh wait, I didn't do it yet. There's one last thing I need to do. I need you guys' help. I need help. What is it? I'm stuck. So close. So close. I don't have n yet. So close. Square it. Yep. If you square this, you'll square this side, and now we got it. We're done. Now we got n. Okay, so, but think about this. Let's break it down. Break it down with little Mega Man. You know, it's my favorite. I need more music. 2.5758 is that z-score. And then we have, oh, I squared it, didn't I? Did I square root it? Oh, no. Uh-oh, wait a minute. Is it this? This was square root, right? P hat, Q hat. I did do that. That is that value. But it'll be squared. Well, let's double check. I've done this multiple times, but I feel like something's odd about that. I feel like something's a little weird on that. Did anyone... That's right? Cool. Hey, if I got it right, I got it right. I think I usually solve this differently. So it's this formula right here. This formula solves out for the answer. It's just a rewritten version of it. As long as we got it right, I'm happy. It can look different. I've done this multiple times. Then I look at it and I'm like, is that the right answer? So 2.5758 times 0.438 divide by 0.05. Square this. It's 509. We go back to our answer. Round to the nearest whole number. We cross our fingers. We say our famous last words to my Pearson. We say, not today. Today was the day, my Pearson. Something looked weird on it. I knew something looked weird. Something looked weird. You didn't square root. This right here. Let me. Oh wait. I know what the issue is. Don't. I didn't carry enough decimals. I think. Before everyone loses hope on me. This right here should be. It should be P. So that's P. I'm still a little worried because it looks different than I usually solve, and I'm wondering if I made an algebra error. Algebra is my downfall. If you don't carry enough decimals, this question will implode on itself like it did for me. And hopefully we get a different answer right here. Is it 511? Were we off by the smallest amount? There it is. My Pearson tricked us. It didn't say we had to carry every single decimal for the whole problem. I mean, who would have thought you have to carry decimals? Not this stats person. Once again, I love using code because when you do it in code, it carries it for you. You go over here to the code, and I think I have the formula memorized right now. P was equal to... Here, I'm going to help someone out here. These are hats. So if you are working the problem right now, I want you to tell me yours, and we'll solve yours for you. Well, why do it that way when we can do this? So there's Q, P hat, there's Q hat. The Z is relative to the confidence level. Well, I'll just do it that way for now. And then we need the... We're solving for N, and we need the margin of error. So it was, if I'm remembering correctly, it is... it's Z times the square root... Z times the square root of P hat times Q hat. That solves. And then divided by margin of error, whatever I put in for the margin of error. And then we go here and we take this whole thing and we take it and we square it. And then we take this thing and we simply round it. And people might be putting theirs in the chat. So that right there is the 511, and that solves out. And personally, once again, this is how I would solve this problem. So I don't have to worry about carrying my decimals. I'll let the program do it for me. You got 180. Alyssa, which one's yours? 25%. Okay, so we're going to change this to 25% right here. 95% confident. That's going to make the z-score 1.96. I'm going to write this another way. Give me 2 seconds. Q norm of 1 minus, let me do this, percent is equal to 90. Now I just had to put that. And so I already got my find z thing. Oh, cool. Yeah, I already wrote it. I wrote it earlier today. So there's the z-score. And that should give me... Oh, but it prints the vector. Don't print the vector. 2 seconds. Return value. Okay, let me rerun this. I'm having a tiny bit of fun here. Okay. So there, that gives the z-score, but yours is 95. And now we should have it, unless I... What's your margin of error on it? 2%? Okay, if I've entered everything in here correctly, then your answer... There you go. You got it. But 1801, it rounds to 1801. Let's take a look at the non-rounded version of this. It rounds to 1801. Double check, 1801. 1801. Because it rounds up. And that's every decimal being carried. So 27, yep. So we got here P hat. Good job, good note. I will only answer your question if you put all the notation. And it looks like you're building a 98% confidence interval from that z-score right there. That's 2.3263. Margin of error 2%. As long as I've entered this in the correct way, there's your answer right there. Change it to... And then, wait, Jose, did we get all yours in there? Jose, did we do it? 25, oh, with 5% margin of error. You know what I'm going to do? I'm going to do one last thing right here. And then, what was the last thing? The last thing was 95. There, ooh, that's a small interval. Let me think about that. Something seems weird about that. 5% is pretty wide. 95%. That seems weird. I feel like something is off. 95%. 5% margin of error is pretty wide. Yeah, it's mine was like a 98%. If you look at the differences here, the difference between Jose's question and my question is my question was a 99% confidence interval. So do you think you'd have to sample more? It's a really good theory question because we're getting the same margin of error but with more confidence. So you would have to sample more. So Jose's interval is less confident. So he would have to sample less to get the same margin of error. Very tricky. Very tricky. So good question, Jose. And did you see the answer? If you didn't see it, ask or rewind. And then you got the environmental agency. So good stuff on this, and that's why we code, because why solve it by hand when code will do it? Can you repeat that? Which thing did I miss right there? Which thing do you want me to repeat? Stop the question. Ow! Pull down my thing. Was it? I think it was. Let's double check. What was the answer? 288. 288. We got it. 288. Oh, yeah. So wait, let me repeat that again. So the reason Jose needs to sample less is Jose wants to be 95% confident. We can draw this out right here. This is a good theory thing to understand what's going on with confidence rolls. Jose wants to be, we're going to do Jose. Jose gets the return of space pen. Jose wants to be 95% confident with a 5% margin of error. Brian, who gets rainbow pen, wants to be 99% confident with a 5% margin of error. So it's a little complex to think about. But if you look at the formula just in and of itself, if nothing changes about the formula, let's look at it. The margin of error is not changing, and the margin of error is equal to z times p hat q hat over n square root. Now, for this purpose, I'm just going to call the top of the equation x. Like, it's just a number. Got it? But n is here. Now, what changes about Brian and Jose's equation right here are what score will change between Brian and Jose's. Anything we do on next, Thomas? The z-score. That's what these confidence levels tell us right here is the z-score. So let's say if we use the same number for Jose, like Jose's number, whatever n Jose found, if we then use this for Brian's, like if I took whatever Jose found, like 288, I think it was. So if I just put 288 in here, which Jose's answer solves out to, but then my z-score changes, what would happen to my margin of error? Since my z-score has changed, my z-score went what? It went up because 95, 99. So my margin of error would do what? Because my z-score is getting bigger. With the z-score getting larger, the margin of error would, you know it, margin of error would, it would change, you are right. Woodley, 50 points, you got it. It would change and it would get bigger. Think going from 95 to 99, you're more confident you'd cover more of the curve. Julio Bourbon to the rescue right here. Ladies and gentlemen, Julio Bourbon. I love it. You got it. So look at the chat. Chat is on fire right now. Oh man, they're on fire. Thank you, Julio. Keep sending what you're doing, man. I love seeing all the stats you're like using in baseball. It's awesome. And maybe when you do that pep talk, more I'll tell you about it, Julio. We can do a pep talk for them if you want, which I'm sure you man, you're just so giving to the students. I really appreciate it. Wish us luck. Yeah, Julio, wish them some luck, man. And we need to do that. We need to do like a pep talk or something. We need to be like, hey, stats one. If you want to do it, it's your call. But you're awesome. So, all right. So to counteract, was it a baseball meeting? Sorry. Oh man, that is awesome. You know, yeah. So you're telling me it's important to understand this stuff. Is that what you said? Like people use this kind of stuff and you'd be like, oh, Z-score? Yeah, that's awesome. It's probably some of the basic stats is a really good tool for anything you're doing to understand like what the Z-scores are. Yes. And you're like, is this how many standard deviations something is above or below the mean? Within 2 is pretty normal, and with outside of 3 is where we see outliers. I mean, 2, 3 is an outlier, but like 4 or 5 is ridiculous. It's just a standardized unit of measurement. It's yes. I gotta start wearing some Yankees stuff here. I don't know. Oh, maybe I should do that. Okay. So, no, you're fine. You're fine. I love it. I love seeing this stuff being applied. That is what makes my day when people are like, hey, I'm actually using what you taught me. I would hate for someone to be like, I'm sure people might not use what I teach them, but I want people to use this. If you're going to get more confident, your interval is going to get wider. Going from a 95 to a 99, the interval gets more confident and wider. So we would see that the margin of error would increase. So think about this. What does the n do right here? What does the n do to the interval? The N would do what? If you're still Julio, if you want to wish them well, be like, you guys got this test. You got it. Feel free to do that. No, it's awesome. I so appreciate you swinging by. What does the N do? Increasing N will make the margin of error do what? How is N connected to the margin of error? It disappears. Yep, I can do that next here, Maya. Or I think we got some other ones. We'll make sure that's on the list, Maya. We got this. How is N connected to the margin of error? What would N do to the margin of error? What would N do to the margin of error? If N goes up, the margin of error does what? If N goes up, the margin of error goes down. So it will make nice job, Andrew. Good review, Andrew, right there. So no, be careful though. Larger samples. Oh, thank you, Julio. Swing by anytime. We got Andrew chilling out in the chat too. Sample size is just related to how many you observe, like how many you take data from. But if you increase sample size, the margin of error will go down mathematically. The only thing that controls confidence is the what? The only thing that controls confidence is the test statistic, the critical value, the z-score. A lot of names we use for it a lot of times. But it's the thing in this position right here controls the confidence level. Increasing that will increase the margin of error, but you can also change the margin of error by changing the sample size. So because Jose's interval had a larger z-score, to counterbalance that, we took a larger n. So the z-score was making the interval wider, my interval versus Jose's, but then I decreased the margin of error by increasing the sample size. That's why mine had a larger sample size to Jose's. So little bit, good discussion right there. We're going to hop back into the questions right here. Let me see. We got a lot on the docket. Let's see. If I miss yours, please tell me. Environment agency worries there are too many cars on the road. And please tell me if I missed it. I can go back and do the other code too. Environmental agency says there's too many cars on the road. Well, okay, there is then. Environmental agency worries that there's too many cars on the road. They're going to clean up those emissions. The agency hopes to check a sample of vehicles in order to estimate the percentage with a margin of error. There's our ME. Okay, I need some help with this 90%. That 90% is going to give me my what score. I need some help in the chat. Help me out, chat. Chat, help me out. I can't. I'm frozen in place till you tell me the 90% is going to be used to find the what. 90% is going to... You got it, Whitley. 50 points, Whitley, right there. Amazing work. 90% is going to be used for that Z-score. We're going to over here to Mr. David Emmaline's site. We're going to say we would like a 90% confidence roll, and he says, of course, 1.645 is your value. These values right here are the same. It's just the plus or minus. So we're good to go on that. And let's go back and look at the question again. What did the question say? We know that the z-score here is 1.645. To gauge the size of the problem, the agency takes 80 cars and finds 12 with faulty emissions. Okay, so this right here is their sample size, and this is their n. What can we get from n and sample size? N and x. From the amount observed and the amount in the sample, 12 over 80 equals p hat. So this right here is p hat, the proportion we observe in a sample. And so we now know p hat. P hat was obtained from out of 80 cars, 12. So they're doing a little bit of trickiness right here. Once again, they're being like, we're gonna trick you with this problem. Not today, my Pearson. Not today. They said they wanted a margin of error in this problem of 5%. Not with highlighter though. Margin of error of 5%. They said they wanted a z-score of 1.645. Why is it 1.645? Because it's a 90% confidence roll. Once again, David M. Lane helped us out with that. We'll drop it in the chat here in case anyone's working this while watching this. Go there and find your z-score. Make sure to do value from an area. Graph the middle 90%, and you will see that you get the correct z-score. Your interval should look like this. Middle 90% shaded. That is the z-score for a 90% confidence roll. Next, we see... What do we see? That we were given p hat. P hat was x over n, so we get x over n equals 12 over 80 equals 15% right here, or 0.15. You got it. Nice job, Hannah. What else can we get right now? You know it. Once you find p hat, what are we going to find instantaneously? We find p hat, we find q hat. P hat and q hats are complements. They complement each other well, literally, because that's what they are. So we put in here q hat, and we got our complement right there. So now we have p hat, we have q hat. And now the question wants, what is n? It says, what is n? And we were like, I don't know. What is n? N is sample size. So now we need to know the sample size for this question, and let's go figure it out. Let's figure it out. Great Nickelodeon show. Old school, because I'm old. And so we need to find the margin of error is equal to z-score, p hat, q hat, over n square root. And I think we can already solve this, right? Because we got our cheat sheet. And I might improve this. I'll solve it by hand here in a moment. But the p hat is this. And the z-score was a 90. The margin error was 5% again. 138. Let's see if we got it. If we didn't, then I made an error in my thing. Got it. What up, Thomas? So let me show just so everyone can see. This turns into an algebra problem. And if you solve, once again, I'll scroll up. You have to mark all of your notation. You have to find p hat, z, margin of error, q hat. And then you go down here and you plug in and you solve for n. You got it. So it's p hat 1.9. Let's do it. Let's do it. We got the cheat sheet. We can do it. Don't tell your teacher. Was it margin of error 5%? Here we go. 236. And I'm going to make this better. Better. 1.96, 95% confidence. Yep. We got that right here. Margin of error. There's margin of error being saved. So let me think right here real quick. So we don't need this. Okay, let me go. I'm going to do one thing. This is Brian having a little fun with this. Fun. Solve for n. Lowercase n. Because it's notation. And we got the find z function. Let's put a function inside of a function. And so let's grab all of our code. Drop it inside of here. And the first thing I want the person to enter in is confidence level. Oops. And then it's 3, not 5. Cool. I'll fix that here in 2 seconds. And then the next thing they'll enter in is p hat. And so I can delete this off. Yeah, because they'll enter that in. We'll be good. I'll break it. I'm sorry. Oh, and then this is where I file solve for that. There's confidence level. Next thing they need to enter in is ME. So that can go away. And this should, and then we got to put return here. Okay. Code's cleaned up. And now we go solve for n. Not that one. There we go. Okay, so it's, you said that, oh, and then Hannah and everyone, let me see here. Here we'll do Thomas's and then Hannah's, and then Maya's. Okay, so we've made it a little easier to work with right now. I'm gonna enter your confidence level. Your confidence level is 95. And then, oh wait, but it wants it as a decimal. I coded it that way. I don't want to code the ifs to not take it that way. 95% confidence, and sorry, my eyes are blurring. And then 3% is the, what's your p hat again, Thomas? Your p hat is 0.19, and your margin of error is 3% right here. There it is. So what does, and then so there it is right there. Does that, if this should be your confidence level, this should be your p hat. Who thinks this code makes a little bit of sense right here? You might be able to follow it to be like, okay, Brian's putting in his confidence level, his p hat, his margin of error. When the code runs, it solves for q hat, then it solves for the z-score needed, and then it solves the equation that we wrote out earlier. If you remember this equation, I'll solve some other people's here, but this equation that we wrote out earlier was right here. So here's the equation it's solving. It's solving z times the square root of p hat q hat over me. So that equation is right here, z times the square root of this over me squared. So it's literally just solving this equation, and then it's rounding it. So it's rounding it for us. So we don't got to worry about getting it wrong. The only way we can get this wrong is if we type in the wrong numbers. So I think Hannah had one. P hat is, oh wait, is P hat 1.5, Hannah? 0.15? And then sample size is, oh, but then there's no sample size for this one. This one doesn't have a sample size. And then wait, Maya's got it in the chat here too. Let me do Maya's, and then we'll revise. Maya's margin of error is 2%. Her z-score is 99 because her z-score is 2.5758. So that's the z-score right there. And then her p-hat is this. And there's the answer. Solves it all for us. Solved. Do understand the theory, though. If you notice, I slow down when I get to the theory. You're welcome, Maya. Tell me if it's wrong or tell me if you missed it or something. Oh, you're giving me the numbers for the original one? Put the whole thing in here, and if I missed it. If you want me to do it, Hannah, double check, and I'll make sure. If you want to say, like, what p-hat is equal to, what ME... to solve these problems, you have to know the notation. And then you have to understand how they work. If you notice, we kind of cover the theory, but then the algebra is just the algebra. It's just solving it. And that's why I like using programs, because it's like, well, it'll just solve it for me. It'll just tell me the answer. Like, here you go. Put in the numbers, answer solved. So that's why I was trying to do the simulation. I spent so long. If any random person is watching this, I was coding away and coding and coding and coding and coding and coding and coding, and there's a vector input. But I was working. It's gonna work. Still need to work on it. Is part of 13 chapter on the test? Yes, chapter 13 is on the test. Have you done the accident problem? Let's do the accident problem. I know, coding night, man. If we can do some in-person coding nights, that'd be awesome. Accident question. We've done the sales company. Accident question. Okay, bear. A lot of these are very similar. Try to notice the similarities. Accident question. Where are you at? Accident question. Oh wait, is that it? That is it? I found it. Okay. Automatically, this asks for a 95% confident for the true percentage, which is the true proportion. Automatically, do you think of an equation when you see this right here? When you see construct a 95% confidence interval, speed run's done. Next speed run. When you see construct a 95% confidence interval, do you think of an equation? Are you like, there's an equation I used to do that? I would think of one. I would think of p hat plus or minus z times p hat q hat over n square root. So let's go ahead and write it. This will help us identify what we need in this problem. We need the following. Well, we need p hat, we'll need it again in a moment, plus or minus z square root p hat times q hat over n. So we now know what to look for. First off, let's find that z. Z is going to be found via what? Does anyone know z? 100 points first person who knows z. This is the famous one. Everyone knows like that. Be careful. Z's and T's are different. We're doing z's, but if it's a t, it'd be close to it, depending on sample size. Mr. T, up the fool. 1.96. Andrew, on fire, knows that classic 1.96. Hannah, Jose, and Andrew, 100 points right there. You guys know it's 1.96. Very classic number right there. Because it's 95% confident. Once again, if you're watching this video and you're like, how'd you get that? What in the world? Go to Mr. David Emmaline's site. Tell him you want a 95% confidence roll, and he will say, of course, it's the famous 1.96, which is very close to 2. Make sure you notice what buttons are pressed right here with the value from an area and the between, and we have a 95% confidence roll z-score. Z-scores tell us the percent confidence, so, you don't got to memorize. If you want to teach stats, memorize them. If you want to get a good grade in our stats class, then use the applets. Know how to use the applets. Or you could Google it, which is acceptable. What is the z-score for a 95% confidence roll? 1.96. 150 points. I like that. Hey, Google everything. Google, how do I get an A in stats? It's silent. It doesn't know. So now we hop over here to here. And we see that we have 561. What is 561 in this 98? It's like in 98 accidents, there was a teenager at the wheel. Is that the question? I think it is. Yep. Yep. And you guys got it. 561 is N, and then 98 is X because it's 98 out of 561. From those numbers, what do we get? 561 equals N. 98 equals X. And we get right here p hat. This will give us p hat. So p hat is equal to x over n, which is equal to, what was that, like 18%? I'm saying 18%. Oh, no. It's like 18.4%. 17.4. There it is right there. We're going to round that to 17.5 for the moment. We are going to carry decimals in the background, though, just for niceties to write this like this. We're going to write that like that. And then we're going to put this right here. You should automatically be thinking about Q hat. Try to solve it in your head if you can't. It's just for funsies because we like to see if we can do it. And we should get 0.825. Double check your work. Never hurts to double check because you solved it in your head. Did you get it pretty close? Yes, you did. I might mess it up. Never know. And then we have n here, which is the sample size, which is 561. This was the whole point of the problem. Also, we should be able to interpret this. I am blank % confident that the true proportion of, we can do direct mail or X, you got it. I am blank % confident that the true proportion of accidents that have a teenager at the wheel is contained in the interval blank to blank. I am blank % confident that the true proportion of accidents that have a teenager at the wheel is contained in the interval blank to blank. Make sure to know how to interpret it. It's always good to interpret your interval after you create it. So, sure, we can algebra this out. You got it. Direct mailer is next. Is it the philanthropic? Did we do? We do. Double check. I think we did. If it's the philanthropic, we did that a moment ago. Double check. I will do it again if you guys want. But double check. If it's the philanthropic, I think we did it. And if you have a TI calculator, the philanthropic one is a lot easier. So there's Q hat times P hat. There's that. Square root. I think, yeah, let's do it next. And then, cool, we got Alyssa's, then Carly's. Let's do it. So there's this portion. I'll hover over it. That's this number. So I'm just going to times that by 1.96. So now that I times it, it's this number. This is now the margin of error. So I've now basically created my interval. I hope I carried enough decimals on that. He'll get mad at me if I didn't. So wait, I copied this. So 98 divided by 561. Okay, that's with all the decimals. Carry all your decimals on your calculator. So I got everything in here. That's gonna be fun to repeat. Okay, here we go, back over here. And now we add to this, and we get 20.6. One decimal, that looks good. And then we take and we get our p hat again, just to make sure we're gonna carry all our decimals. We subtract from it the margin of error. We get this right here, 14.3. And that's got it. And I think there's a way I can check this. I'm gonna do something real quick inside of R. Propt test. Cool. X, N, and P. Cool. So X was equal to 98. This was equal to 561. It uses chi-squared, though. So I don't know how accurate that is. 14.4, 20.9, and then it does 95 by default. But I think it's using a chi-squared, so I can't use that. Unless I made a mistake in my math. We are 95% confident the true percentage or true proportion of accidents out of a teenager at the wheel. You got it. Make sure I read it properly. Because we're trying to estimate the true proportion. Explain what the 95% confidence means. 95% of random samples will produce intervals that contain the true parameter we are interested in. The true population proportion, the true proportion. That's what we're interested in. Polluting a politician urging tighter restrictions says, he says,
in one of every 5 accidents, a teenager is behind the wheel. I am a politician. In one of every 5 accidents, a teenager is behind the wheel.
Uh-oh. Oh, man, he's usually wrong. What do you guys think? Do you believe the claim or do not believe the claim? Do you believe the claim or not believe the claim? I kind of gave it away because I said he's usually wrong. Believe the claim or not believe the claim? He said 1 in 5. Someone, 100 points, post the formula sheet for Morgan. It's on the Stats 201 webpage under exam 2. With all the help stuff, you'll see formula sheet. We should believe random politicians' claim because, thank you, Hannah, very much. We should believe random politicians' claim because it's in the interval. So since it's in the interval, the confidence interval contains the assertion of the politician. The confidence interval the confidence interval supports. There it is. The assertion of the politician because it's inside of it. Does that make sense right there? Let's double check. Not today, my Pearson. Not today. Give me a heart attack, my Pearson. Because he says 20%, 1 in 5. Just the math right here is 1 in 5. So we ask ourselves, is 20% contained inside this interval and 20% is inside the interval? Does that make sense right there, Hannah? The claim is 20%. And we're not saying that is the truth, but we're saying that that's believable. So does it support his claim? Yes, it does, because that's a figure that is inside the interval that we believe could be the true proportion of times that a teenager's at the wheel. Because we think the true proportion of times a teenager's at the wheel could be contained in the interval 14.3, or I'm 95% confident the true proportion of time that a teenager's at the wheel is in an accident is contained in the interval 14.3 to 20.6. And so thus 20 is a believable number. We would not reject it. More on hypothesis testing coming up next. So we got some more questions right here. Let's do another one. Hey, wait. We got... Hey, Darren, you are on the internet right now, so you are talking on a live YouTube channel, just so you know that. Got it?
I love the YouTube channel. What are you teaching today?
I am teaching... We are doing confidence intervals for the true proportion. Have you started doing confidence intervals in your class?
Yes, we have. Very nice thing to learn about.
Awesome. Yeah, no, and I was telling them that you were doing sampling distribution of the sample proportion just like last week. The sampling
Yep.
Yep.
Yeah,
Have you...
Brian's a very good teacher.
Well,
We understand it very, very easily.
Well, thank you. I wonder, I think... Well, Darren, I will let you go, and I'll talk to you later, and we can talk some more stats, but that's got it.
Sounds good. Have a good day. Bye-bye.
Awesome. See you, D-Man. Bye. Cool. Yeah, Darren's taking the stats class. Did the Haslam magazine come out yet? Then, yeah, no, I got the preview of the article. I bet I could send you that, Andrew. So I'll send you that, Andrew. I was like, my brother's hopefully not gonna make some like crazy joke. He's gonna watch this there. I was like, you're on a live YouTube channel. So, like, will that make him say something crazier? Like, do not say something like, yeah. Like, it's so funny. It's like, like, I used to be, like, I was like, I'm gonna broadcast online every day. And I was like, well, I guess I am. Be online every day. On the internets. I think someone wanted the catalog sales one. I'm gonna do Jared's problem right here. Yeah, let me, email me, Andrew, and I'll send you it. I'll send you the preview of the article. I think you're in it. I think your name's in it. Yeah, thank you, Hannah. Yeah, that was really awesome. We got and we're gonna use that to do like more online teaching. We're setting up the mobile studio. So thank you so much, Hannah. Like, maybe I don't know. Maybe I should log into Facebook and do some stuff right there. But, no, thank you so much. No, that's, I really appreciate it. Like, a lot of people have given me so much support, and it's really, really positive. Like, you guys have been so awesome. So, no, it's like really good, like good stuff. A catalog company. Did we do this one? I think we did this one, right? I think we did this one. We did this one, right? Wait. Editors preparing. Editors preparing. Here we go. Several factors. You got it, Jose. We'll do that one next here. Editors preparing a report on the economy are trying to estimate the percentage of businesses that plan to hire additional employees in the next 60 days. They are willing to accept a margin of error with 95% confidence. How many randomly selected employees need to be contacted? This one is the tricky one. This one right here does not give us, can we identify the notation? That is the margin of error. This is going to go to the z-score. But it does not tell us a certain thing. It does not tell us p hat. Without p hat, you might think we're stuck. But what would you assume? You got it, Jared. What would you assume without knowing what p hat is? Just take a, like, well, if I don't know what p hat is, maybe I should just use this. If you don't know what p hat is, what could you guess p hat to be? Like, just say, well, I guess I could just assume it's this. It's a weird thing to do, but people do it. It's like the safest p hat to use if you don't know it. You just kind of say, well, I guess I'll put this value in for p hat. The safest p hat to use is what? It's tricky. It's a tricky question. What if I said, if we ask people if they like Coke or Pepsi, and we say you can only pick Coke or Pepsi, and I know Coke's better. I agree. Coke's better. But 50%. Yep. 0.5. 0.5 is the safest p hat because it gives no preference. So this question right here is simply solving the equation right here for n. This is another solve for n problem where we have to solve for this right here. And so plug in your numbers, but 0.5 and Q and P hat are 0.5. Z is related to your confidence you are in it, and the margin of error is given to you, whatever it says. Solve for n, and the problem is solved. And so we have to go into here, and we do our solve for n. So we put in this. This is our P hat. And then we put in our margin of error. Was it 5%? What did it want? Margin of error. 1%. We do that. 9,604. Whoa. Did I do everything correctly? I think I did. 9,604. Round up. Oh, no, no, no. Okay, so this will mess us up right here. And we have to change this. We have to go solve for n up. And then we have to go here to ceiling. Okay. And then we have to rerun our code with this. 9604. So, wait, what? Oh, it was 9604 the first time. I just mistyped it. I'm on this question in 60 days. Could do it 2%? Yeah, let's do it. These are my least favorite problems. Did I get it right? Is my code working? I got it right. What does it want? It wants, what percent? Was it Hannah? It wanted 2%? 2%? Boom. Done. Solved. Answer. Solves it all for us. If you're working it by hand, if you're watching this video later, I do usually give some, if you're watching live, I'll help out with stuff like that. So that's the benefit of watching live. But what you need to do now is, if you're watching the video later, is you need to put in your z-score, which is found via the David Emmaline applet. Once again, to show the David Emmaline and drop it in the chat. We send everybody his way. Is you need to go to the David Emmaline applet, find your z-score, which this is the z-score for a 95. I think we were using that, so this would be 1.96. Go back to your notation, put in 1.96 here. P hat and Q hat are 0.5. Your margin of error is what your margin of error is, and then solve for n, and it requires some algebra. We did shorthand this out a little while ago, and the shorthand we got is the following. So if you're solving this, you can use this right here to solve it. So this will actually get the answer of P hat times Q hat square root Z over ME solves for n, because we algebraed it out by doing all the steps right here for a previous problem and with my handwriting. So we did that problem. We got it done. And then notation. Can we still do it? Just believe that 24% never graduated from high school. You got it. It is believed. It is believed. Do that one. That one tricks. That one gets me every once in a while. It is believed that as many as 19% of adults over 50 never graduate from high school. We wish to see if this percentage is the same among 20 to 30-year-old age group. What sample size would allow us to increase our confidence to 95% while reducing the margin of error? Okay, so when you see 95% confidence, what z-score do you think? Who's got 50 points in the chat right now? When you see 95% confidence, what z-score do you think of? Oh, I think got the true and false ones. Let's do that next. You bet, Hannah, we got it. What do you think when you see 95% confidence? What do you think of immediately? You're like, I should find the what? The z-score. That's, 1.96, which is the z-score. When you hear margin of error, you know that this is the margin of error. So they want a margin of error of 2%, a confidence level of 95, and they want to find the sample size. What is this right here? This is what? This right here, this number right here is what? It's what we're going to use as this. We're going to use this as our P hat. So once again, you can tell this is a very similar problem to what we've been doing. It's one of, how many sheets do I have open today? Too many, that's the answer. It's one of the problems we're going to do where we solve out this right here, where we solve for the n by using the margin of error, the z-score, the P hat, the Q hat. And we go right here, and we can see the simplified version of it, where we find the P hat, the Q hat, the Z, the ME, and we find the N. Once again, watch the earlier questions where we went a little bit slower. But the good news with code, good news, everybody, is we put our margin of error here of 2%. We put our P hat of, and then we put here our 95% confidence roll, and we do solve for n right here, and we get 1478. All my code is doing, it says round up. Why? Why round up? 1479. That's my round up function. There we go. And we check our answer, and we got to write. Double check. There could always be a problem like this on the test. You never know. This would be a very small portion of the test. You never know. But I would not spend a very long time practicing problems like this. It's more important to understand theory. So the true-false is going to be more important. Once again, if you usually see me doing something quickly, like I just did right there, which I did slower the first few times, but I would say these are the less important problems for understanding how statistics works. So these are the less important problems. I mean, you should still know it. It's algebra, but that's why I'm like, it's algebra. It's not stats. I want to do statistics. Okay. Here's some tough questions. I need your guys' help. I have gotten one of these wrong before because I've been like, wait a minute. It's the famous true-false that everyone is like, I don't know. Here we go. For a given sample size, higher confidence means a smaller margin of error. For a given sample size, like if you keep the sample size the same, higher confidence means a smaller margin of error. So all we're going to do in the equation right now is change the z. So let's look at the equation. If we go here, does the sample size of 40 seem larger? That's way too small, Josh. Double check your work. Put your numbers in the chat. I'll solve for you. Higher confidence means smaller margin of error. True or false? False. Because the z is going to get bigger. If the z gets bigger, then the margin of error gets bigger. Higher confidence is larger margin of error. So that's very false. Really good true-false question. Very false, unless I'm... Everyone knows it goes true-false. Oh, maybe you could. Maybe you could. Possibly. For a specific confidence level, larger sample... Let me double check. For a given sample size, higher confidence means a smaller margin of error. Yeah, I think we're right. Put your numbers in the chat, Carly. I'll double check it for you right here. For a specific confidence level, larger samples provide smaller margins of error. So now it's saying, let's double check, you ready? Now it's saying if you are to keep your confidence level the same, but increase this right here, that's very true. Because if you notice, the larger n right here will make the margin of error smaller. So that's very, very true. Larger sample size, smaller margin of error. Where's the true at? It's up there. For a fixed margin of error, larger... Okay. This one's tough, and I think this is the one I've gotten wrong before. It's saying that we are going to keep the margin of error of something like this. The margin of error is going to be this no matter what. So, this is the weird one where I sometimes have gotten it wrong. For a fixed margin of error, larger samples provide greater confidence. So, okay, I want you to pretend this is not fixed. If we had a larger sample, what would happen to the margin of error? Just pretend it's not fixed for a moment. If we have a larger sample, what will happen to the margin of error? With a larger sample, the margin of error will do what? If we have a larger sample, the margin of error will go what? Larger sample, margin of error will go. Well, look what the larger sample will do. It'll make this number bigger. So with a larger sample, the margin of error, which is this, will get water. It solves to this. It'll get smaller. So since we've fixed this number here, what can be used to counterbalance this number getting larger? This number getting larger, which will make this smaller, which will make this smaller, could be counteracted by another number changing. We don't really control p-hat. That is true. P-hat could change it, but we don't really control that one. There is something we control, though. Our level of confidence. So we can control this. And these two right here will kind of fight back and forth, and they'll counterbalance each other. Does that make sense? Like, if we increase, like, we're keeping this number over here fixed, but we can increase the sample size, and we need to increase the confidence to keep it fixed. Because if we increase sample size, it makes the margin of error go down. If we increase confidence, it makes the margin of error go up. So we've got sample size increasing, making the margin of error go down, but we've got confidence level increasing, making the margin of error go up, and it kind of keeps it steady. And you can do that. Like, you can have your fixed margin of error. I don't really do that. So that's very true, unless I got it wrong. For a given confidence level, having the margin of error requires a sample size twice as large. We saw this earlier. We saw this yesterday. Theory question. If you are to take half the margin of error, which could be solved via the formula Z. I don't like that color. I like space pen. The margin of error is the following formula. So if we want to times this by half, what do we need of the sample size? We don't need twice the sample size. We need how much times the sample size? 100 points, who knows? How much times the sample size? Because we just want to times it by half. We don't need twice sample size. Square root of what? Not 2, though. Of 4. You got it. Yep, because that solves to 2. And then you can multiply this out here, and you'll get half you'll keep the same. You don't change Z because Z is the confidence level. So this will get us half the margin of error. So this is very false. Did we get them all correct? Not today, my Pearson, not today. Some people had some questions in here. Let's double check the work. Let's go back into R and let's take a look. We have P hat equals this. This is my P hat right here. Is this a round up or round down? So make sure if I'm putting this in here that this is either a round up or a round down. So this is going out to Josh right here, but this is the round up version. That's the round up. Be careful. You see where it says round up function? This is the non-rounded up. So if the problem said to round up, this is the answer. If it said round up, if it didn't say it, could you do it not using R? Yeah, let's do it. So to do it not using R, which is not the fun way, let's take Carly's numbers right here and go to not using R. Let's do it. Okay. So we're going to use our shorthand right here because we've already... My gosh. Number I don't know, so they don't get answered. So this is the shorthand we got for solving for N. And Carly's numbers were... Carly, you get 100 points asking for not R. I appreciate that. If you're like, I just want to see it normal. Carly said her Z-score is 1.96. We're going to do that. 1.96. Because 95% confidence, we have here that we need to do square root of 24 times 0.76. And then we go to the margin of error. The margin of error was... Oh, you're welcome. No worries. Margin of error is 2%. So plugging in the numbers right here, you guys are always free to say, don't do it in R. And I'll say, okay, no more R for now. And then wait. Was it squared? It is squared, isn't it? There's an error. There's an error. Uh-oh. Sorry. I was like, we squared it, didn't we? Oof. Some people are going to see that in the video and be like, wait a minute, it didn't work. So that quantity has to be squared. So make sure to carry your decimals. That's why I like doing programming, because it carries the decimals for us. And so let's bring us over to here. Oh, see, everyone's... Thank you, Carly. We got this. Square root of this. Divide by 0.02. And then square this, and there's the answer, Carly. Round that up or round that down, depending. Oh, you didn't square it? Carly. I am so sorry. That is completely my fault. I am so sorry, everybody. I wrote it out for you, and then I forgot to square it when I did it in notation. When I did it at first, I squared it. You didn't forget to square it. I forgot to square it. Carly, you getting 200 points. You totally helped us out by saying, I did what you said, Brian. The direct mail. Yep. Take a look at it here in a second. Is the philanthropic? Put the star of the question in here. Put the star of the question. The exam closes at 11:59. You're right. We've done all the homework. Is there a specific homework one you're wondering about, Alyssa? If there is, feel free to ask. So if it's 5%, would we get a range? That would not be plausible. That is correct, Jared. You got it, Jared. Yep. Direct mail. Let's take a look. Let's go right here. Let's see. Direct mail. Direct mail. Where you at? It's got to be this one, right? Direct mail. Let's do this. So here we are. Chapter 14 homework. Yes. Chapter 14 homework was done. We did the confidence interval one. Chapter 14 confidence interval homework was done at the very end of class. So double check. And I haven't marked the video yet. But I'll go in and I'll add the tags to the videos. But you'll see me doing chapter 14 confidence interval homework. Does that make sense, Alyssa, right there? Good questions and good work. Let's see. Direct mail advised and solicits junk mail to thousands of customers. The response is usually quite low. Suppose a company wants to test the response rate to a new flyer. It sends out 1,200 people randomly selected from their mailing list of these many people. Be very careful. I want to see some notation. This problem tricks many people. What is the notation for this problem? This problem catches many people with the wrong notation. Be very careful. You have 3 numbers to deal with. And this is where I see the mistakes in this problem a lot. We have 1,200 people were selected out of the 200,000, and 109 of them get orders. It's tricky because there's 3 numbers. They're trying to trick you. So who knows one of the numbers? Don't worry if you're wrong. I'll give you 100 points even if you're wrong. Anyone know any of the numbers? Great job, Josh. You are right. The 200,000 is the population size, which we're not going to use. So 200,000 is not used for this problem. That's where people get tricked. So now that it's in the chat, I can solve it in the chat. So, oh, awesome. And we'll do that tomorrow. How's that sound for you? So, because I might need some more coffee. Drink all the coffee and then I start streaming. Let's do this. You got it. We're ahead of the game. We got a chapter done today that we don't even have a homework due on. So we are ahead. And so there we go. P hat is equal to this. That's the worst 9 I've ever written. There we go. You're welcome. Great job. You guys, drop the pen. Brian drops his pen. That's the way it goes. You guys are doing awesome. Thank you, Alyssa. Okay. 109. It's like 8%. No, it's like 9.05. 9.01. So 9 point, yeah, something like that. Cool. 0.09. Oh 9 oh 8 3 3 3 3 3 3 3 3. And now we're making a confidence interval. So what do we need? Everyone knows what we need. Someone's got to tell me in the chat since we're doing a 95% confidence interval. 95% confidence, you should be like, I know that one. I know 95% confidence. Z-score, Josh. Amazing work. 100 points, Josh, right there. You can get 200 points during these crazy office hours right here. So we got the Z-score right here. The Z-score is 1.96. Now that we have all the information, we simply go right here and we do p hat plus or minus the z-score times p hat q hat over n square root. And that's got it. We got this right here. And we plug in the numbers. 1.96, 0.09, sure, 1, times 0.9, can't think, 09, I think that's it. We can carry more decimals in the calculator. Sample size is 1200, and then 0.091. Cool. I think it's got it. It seems correct. Okay, so now we go right here. We do p hat times q hat. Let me double check. I did that a little quick, so I'm worried. P hat times q hat over n square root. We have the standard error. Times that by z. There's that. And now we go over, and we go back to our problem. We take the sample proportion, which was 109. And then we add to it that, and we get 10.7 rounded. And then we take 109 divided by 1200. And then we subtract, and we get 7.5. And let's see right here. If I missed one question by 0.2, send it to me, Hannah. It depends on how many decimals were on it. If it's a confidence interval, you might need to redo it. Depends. Double check, Hannah. It depends if it was like, send me a screenshot. I'll have to see. Some of these can be very close. It depends on how many decimals there were. Let me see, and I'll see. You're good. Great job, Alyssa. We are 95% confident that the true percentage of people who will respond to the flyers contain the interval. About 95% of intervals will contain the true proportion, and the company wants what, 5%? Oh, they got that. Yeah, they should do the mailer. Yep. Awesome. I think we've done pretty much all the questions. This was question number 11. Question 9. We did this one. This one's in the earlier video. This one's in the first video, the philanthropic mailer. We have here X, we have here N. We can get P hat from that, and the Z-score is 1.645. Put those into the formula, solve, and then see if 5.7 is in your interval. And that one's solved. So that'll do that one. And then this one right here is in the other video too. Oh, wait, I am blank percent confident that the true proportion of ores that arrive in the intervals contain the interval. There. We got that one done. Hey. You know what that is? That's this one right here. We got to do it. We got to do all of them. We got to. I might say in the email, like, make sure to use subject title, this. I might do that, or in the reply. Do I have to solve it? Do I have to put the numbers in, or can I use R? Do I have to put the numbers in, or can I use R? Can I go over to R and just go over to here where I did this and put in 5, 3, 4, 5 for P hat, solve for Q hat. What's my Z-score? My Z-score is 90%, which I already got. And then there's the interval 5.23 to 5.46. 5.23 to 5.46. And that's not plausible. It's outside the interval. There we go. The company must decide what to do a mass mailing. The mailing won't be cost effective unless it produces at least 6%. Is 6% in your interval? Well, what they're going to do is, so I'll go back. That's question 11. I now know the numbers of the questions. They're going to look at this right here. They'll do the mailing if they can get at least 5%. So you're trying to estimate the true proportion of people who will respond to the mailer, Josh. Does this make sense? Do you think they should do the mailer? Because they think the true proportion of people who will respond to the mailer is between 11 to 14%. I rounded it. They think the true proportion of people who will respond to the mailer is somewhere in the interval 11 to 14%. They want to see at least 6%. Wait. Remember, it's responding to a mailer. It's a good thing. Like, that's, I think, where the confusion can be on this one. They want people to respond to this mailer. Like, that's good. And they'll do it if they can get at least 6% responses. So the question is not, is 6% in the interval? It's, they want to get at least 6%. And even my interval right here would say that we think that between 7.5 to 10.7% of people will respond. And so with your number of 6%, I would say, let's do this. We think the true proportion of people who will respond is above 6%. And just think about this right here. Yep. Nice job, Josh. Thanks for going back to this one. I know sometimes I do them a little bit quickly. When you see it, you're like, oh, we're not asking, is it in the interval? The idea of doing the mailer is if we can get more than 6%, we should do the mailer. And they think they will get more than 6%. Good one, Josh. Good question. Play a little Mega Man here to get hype. Let's Punch Out. I need more music. We haven't gotten in trouble for playing Punch Out and Mega Man and Zelda and Mario, so I'm like, it works. Any last questions? Ask your last questions before we get going here. Awesome, Anna. Good job, everybody. It is time. He's going to make his return.